Yes.
And okay, so last week, and we did a kind of quick tour of how to do web development, creating simple HTML pages and add some JavaScript code to it. And the reason we covered those is because we want to actually create validations and using JavaScript and HTML. So that's what we'll be covering today. So the particular library we're going to be using is called Vega-Lite, and it's a JavaScript library. It makes creating visualizations much easier in the sense you don't have to write much code at all to create a visualization, but there's still a few things and you need to know about. And also the other good thing about VegaLite is actually you can use the same way and to create visualizations in other programming languages, for example, like Python. It's very similar code, if not exactly the same. Okay, and so there are many different ways and to create validation. And so far we covered Tableau. And so that's one way to create validations where you don't need to write any code. And there's also something like a D3. And compared to Tableau, it's a much lower level and validations. And in D3, and you need to write code, but also you actually need to write code at the level, say, you have to draw each single line and points in the validation. For example, if you want to let's say bar chart, then you have to draw two axes yourself and add tickers and labels on each bar. And for each on each axis, on each bar, you have to draw the box, the 4 lines yourself and coloring it, etc., etc. So that's a much lower level. You need to write lots more code to create validation. And then the advantages will be you have full control. You can decide exactly how to draw each bar chart or any other graphics that you want. And then also something like a ggplot, which is a quite common one used in R. And it's mostly used to create static validations in the sense you're not really meant to interact with it. But it also, you probably need to write much less code compared to D3 to create a ggplot. And finally, and there's something like a Vega, and which is another kind of language that you can use to specify or programming validation. But Vega itself is still, how do I say, you still have to write quite a bit of code, even it's less than say a D3. Okay, and so the main idea in Vega or VegaLite, which is like the light version of Vega, is to allows you to build visualization that like you would build something using Lego blocks. So you can take in simple blocks and compose them or add them together to create more complex ones. And so at the beginning, we're going to talk about how to build a single block. And then we're going to talk about how to put different blocks together to make a more complex validation. Okay. And so in a sense, the language is based on the idea of creating a grammar of graphics. So it defines the important things in the grammar, or if you want to have a language to describe graphics and different types and how they should be put together to create a validation or describe a validation. And so you have data, so which are the source or the underlying data which decides what the validation would look like. And then you have transformation. So these are the transformation of the data itself. So you might filter some data. So that means you hide some data, not show them in the validation. You might do aggregations again. So you're not showing all the details, but instead you're showing, say, average or mean or minimum or maximum. And you can also do binning as well in the system of and do a calculation. A typical example will be creating a histogram. And in this case, you're not showing You're kind of doing aggregations, so you're counting for different value ranges, how many points are there. Okay, and the next important part, and forming the graphics, is the mark, which we covered before. That decides how you represent each data point, so each data items in your collection. So each row, if you have a table, how that will be decided, and depends on how you decide the mark. You have different types of graphics. Okay, and then the next important part is the encoding, or what we called, sometimes also called visual mapping. Essentially, is deciding which channel to use to represent the attributes of your data items. So I'm going to use color, position, or size, or something else. And finally, not finally, and there's another important thing is called the scale, and that decides how the data values are mapping to the visual attributes on the display. So usually this is linear mapping 1-to-1. So if it's and value 1, it will has a unit length or size on the screen, and if it's 2, it will have 2. But sometimes this can be different. It can be non-linear, say it can be logarithmic, or even say you might take out a certain part interval out of the values. That's the scale. And finally, the guides. So this is something we didn't quite talk about specifically in so far, because in Tableau, this is all done automatically. And if you program the visualization yourself, you do have the choice to do this differently. And so mostly the guides here means the axis and legends. For example, and what are the labels for the x-axis? So how often do you have a tick on the label? Is that every 10, or is that every 20, or every 5? Okay, so these are the guides, what they call guides here, and still quite important part of the visualization. But usually in many cases, you don't really have the full control, for example, in Tableau. Okay, and so as we mentioned before, and these three and Vega are the examples where you have fine-grained controls of graphics in terms of you can control all the details you want, but also, and that takes lots of code and to write a very simple graph. And can I see a show of hands? If you please raise your hand if you heard about these three before or even used it. Anyone at all? No? Ah, okay. I mean, if you do any validations in JavaScript, that's probably the first one you would heard of. And it's used in many other higher level. There's lots of other JavaScript library which is built on top of the D3. Okay. And there's also the other side of the building validation. So the Tableau we saw before, and then ggplot. And so you need to write much less code or even no code at all in these cases, and which allows you to create validations faster, but also it gives you less control. And can I see a show of hands now and say anyone who kind of heard of or used ggplot2 before? Okay. Yeah, so there's some people using R and they would have used a ggplot. Okay. Thank you. So we're going to go on. And also, especially for ggplot, and the support for interaction is a little bit limited because it was not what it meant to, was initially designed for. Okay, and so VegaLite, and the goal is to facilitate exploratory data analysis, and in the sense, so you want to use the validations to find answers or find something from the data, and which is what we mostly covered in this module. And the opposite of the exploratory data analysis is to present the results to someone else, and some people call it explanatory validation. In that case, it's a bit different in the sense that you already know the answers, you just want to show other people. And so the validation you created could be similar to exploratory, but the goal is quite different. Okay, and it wants to be expressive and concise, and in the sense, so you don't have to write too much, but you still have quite a bit of control over what the validation looks like, and you can specify interactive multi-view graphics. So interaction is a focus of VegaLite, so they want to make it interactive. And also multi-view, that means you can create more than just a single chart, and something similar to the dashboard you would have in in Tableau, so you can have multiple views in one visualization. Okay, and so these are some of the charts that can be created in VegaLite. And today we're going to start with actually a bar chart, not even a histogram. So these are the fairly standard ones you can create quite easily with a limited number of very few number of lines.
Professor.
Yeah.
Professor, VegaLite has more of a drag and drop part or more of a coding part? Because ggplot has everything related to coding, nothing for a drag and drop.
Yes, yes. Okay. So we'll see very soon in VegaLite, there's no drag and drop. You have to write everything in code. Yeah.
Thank you, Professor.
But the code, it tries to reduce the number of code you need to write. We'll see, and very soon in examples. Okay. And so these are the so-called multiple view graphics. We're going to talk about this a little bit later on, and it's called the scatter plot matrix. I can't remember if we covered previously, but here it shows you the pairwise relationship if you have more than one attributes. And so you can have three attributes on the side, this side on the x-axis. So you have the maximum temperature. They're all maximum temperature. And so you have maximum temperature. This is maximum temperature versus itself. This is a maximum temperature versus precipitation. And then this is the maximum temperature versus wind. So essentially you have three attributes: precipitation, maximum temperature, and wind. And you can create a pairwise relationship between these three attributes. So that's why, and in the diagonal is an attribute towards itself. So it's always a straight line. And then this part and this part are the same, but they have different swapped axes. So if you look at this one, it says, probably very small on your side, it says wind versus precipitation. And this one says precipitation versus wind. It just like flip or mirror the chart along the 45-degree line. Anyway, this is one of the so-called multi-view graphics. You have multiple charts in the same view. And this is another example of multi-view. You have three charts in the same view, and on the x-axis, they share the same x-axis as all and months or time, but then on the y-axis, you show the wind, the precipitation, which just means amount of rainfall, and maximum temperature. Okay, and so finally, we have faceted views. Again, it looks quite similar, but it's actually not three charts, but only one chart. And each X or each part shows slightly different attributes. In this case, and each of these axes actually all shows miles per gallon, and this part shows all the red cars, which are the cars made in the USA, and this part shows all the cars from Japan, and this is blue one showed all the cars from Europe. So each of these charts showing a subset of the entire data set, and that's called the faceted view. Okay, And we probably don't have time to cover these more complex ones, but we should see some examples next week. And once you understand how to create them, and you only need maybe a few more lines just to create these more complex visualizations. Okay, and here I'm showing some more examples of interactive visualizations. And for this one, you can move the mouse cursor around, and depends on where you are, and that point will be treated as 0, and everything else get updated. And this one is a bit different in the sense, and these are linked views, and you can make a selection in one of the charts, and then the same selected part will be highlighted in other 2 charts. For example, now these bars get selected in this histogram, and then the corresponding part is highlighted in other 2, because each of these parts is not an entire bar anymore, so it's only highlighting certain part of these bars in 2 different views. Okay, and this is another one, and called the focus plus context. So this will be showing the overview of an entire data set from year 2000 to 2010. Then you can select a single part and you can have a more expanded view here to see the details of just selecting the part. And as you change the selection, either in terms of time or the size or the range, and you have different expanded view here. So which is what you see. So first make a selection and you can move it around, and this part moves accordingly. Okay, and so we're seeing these 3 parts, and you can just create a single view, which is one chart, and you can have layered and multiple views. This is one view with multiple charts, and then you can have interactions with selections. So that's the last one we saw. You can show focus plus context or link the view between linked selection between multiple views, which is also called brushing. And so we're gonna start from the single view specification. Okay, the general idea is you want to map data into visual representation. So in terms of abstract data, and it's the table ones we have, and which is very similar to the type of data we had in using the Tableau case. And you decide some visual representations. You pick a mark and pick a channel, and then you can create a visualization out of that. So, and we're going to start with something is called a VegaLite online editor. So these are some things which you can try out some of the visualizations very quickly. But later on, actually for the coursework, and you're going to create your own HTML file and add your visualizations to that file later. It's not that much more difficult, but we'll probably start with the VegaLite as an example. Okay, and in this particular case, and it's showing the amount of precipitation, which means amount of rainfall at Seattle, and they want to use this and create something called a strip plot, and in the sense, each value will be shown as a line, and it just says, okay, there's lots of, you can see there's lots of lines between 0 and 60, sorry, 0 and 10, and the largest value is somewhere between 50 and 60. So that's called strip plot. And these are the lines of code that you need to do it. Okay. And so the way to define this is very similar. So here we pick the mark, which is strip, and it doesn't necessarily mean this is the best choice. It just says this is as an example to demonstrate how to use VegaLite. And use the x-axis, the position as the channel to represent the value. And this is, as we know, a quite effective channel in terms of showing quantitative values. Okay, and if you need to write this, and first you need to specify the data. So you need tell the code where can I get the data. And in this case, and the data is online, so it only writes, say, URL weather Seattle.json. And we're going to see a little bit later on why that is the case. And then you need to say, okay, you need to set the mark. In this case, I said it's want to be tick. And the strips, or in the VegaLite, this is called tick. Then it'll give you these lines. Okay. And then you have to specify the encoding, as what I said before, specify the channels used to represent the value. So you need to say, okay, this is one of the channels, which is the X position, and it's going to map to this attribute in our data. And you need to pick the right name. In this case, it's called temperature. And you also need to set the attribute type. Again, we covered that before. So because it's temperature and the type is called quantitative. Okay, and that's all you need to do. And then the VegaLite will create this one for you, and it will create the exact axis and map each line, the position of each line, to the values of the temperature in this particular JSON file. Okay, and so before we go any further, so this is just to explain, and actually there are lots of other things and that VegaLite did in the background to how do I say, did in the background, so you don't have to specify those yourself. And for example, it spells the scale. In this sense, it defines the minimum and the maximum values, which show you on your axis. So it automatically tries to calculate some values based on the data it has. In this case, it picked between -10 and 40. So these are because all the data are within this range. Slightly weird, has some values less than 10 or less than 0. And also, and things like what will be the title for the axis, and whether you have these grids and how each grid is 10, and also something decided by the VegaLite and automatically for you. And you can change these if you want. For example, you can definitely change the titles for the axis if you want to. Okay, and we're going to just have a quick look of this in the actual VegaLite editor now. So I should have a link here. I need to stop the other one. Okay, so let me put this one aside. Okay, I'll make it a bit smaller so we can still see the slides. And okay, and I just want to check, say, is the text in the editor big enough to read? So for these text, can you see on your screen? Is it too small or?
It's visible, Professor.
It's visible, Professor.
Okay. I'll make it slightly bigger. Make this side slightly bigger and make text bigger. Okay. And so that's all you need to do to create a visualization like this. And the idea, so the main thing, if you remember, is you write what you really only do to specify the visualization is you creating a VegaLite, a JSON object. And so if you could see, and if you remember a JSON object, it always starts with a curly bracket and ends with 1. And then in between the curly bracket or inside the curly bracket, you have these key and value pairs. So in this particular case, it automatically generates a key for you called $schema. and its value is this. Oh, it's now already version 5. That's a new version. And you write more. And in this case, do I have a bigger version here? How do I go next slide here? I'm not sure if it is any bigger. And so all these are actually also just key value pairs. So you have the attributes called data, and this will be the part, the value for data itself is another JSON object. This might be easier. It says mark, which is key, and its value will be tick. And you can see there's comma at the end of all these. That means that's how you break or separate different key value pairs in VegaLite. Okay, I'm gonna just, and in the online editor, or maybe for you, if you want to try, just search for VegaLite, and you would go here. That's probably the first, and just use this one, try online, and it should go to the VegaLite editor. And okay, in this case, it starts with some errors, which is completely fine. And you write your code on the left-hand side, and if it's all work out, then the right-hand side will show up with the actual validation. Obviously, currently we don't have anything yet, so you have some error message. Essentially, it just says you need some validations. You can't just say the schema. Okay, and the first thing is you need to use comma, and every time you break something up. Okay, so first thing it says we need to tell VegaLite and what things we want to use. What's the data we want to use? And in this case, we're going to using date, and which is URL. So you actually have to put double quote around the old attribute name. And this is not required. Actually, when you write the code in JavaScript in HTML file, you don't. And it just for this online editor, you have to use this. And then in this case, we're not using any local file. I'm going to using a file which is hosted online. So I'm going to say URL in this case, and just use weather/Seattle.json. Okay, and so .json means this is actually a JSON file. Actually first, and things you need to pay attention to is every time you get this like a red line underneath, that means is it error? And if you look over it, this is it didn't tell you what the error is, but maybe this one would, yeah. So this actually tells you the error is, but I know it's actually because I didn't put them inside a double quote. That's what it's expecting. It just wants everything to be in double quotes. And you still had error, which is this one here. And essentially it just says you don't have the validation yet, which is fine. And we'll have more once we get there. Then you use comma again. Then you specify the mark. And I have to get used to this. And mark. I think single quote is also okay. So in this case, I'm going to do tick. Wow, even single quote is not okay. It has to be double quote. Okay. And then do the encoding. Okay. And for the x-axis, I'm going to using the field, which is temperature. Okay. So, and then its type would be quantitative. Okay. So now, you can see the error message disappears, but you still have some warnings here now. And so it's instead of red, it's yellow, and it's loading failed. So basically what happens is it couldn't find this particular file. So actually these files are stored online and in the VegaLite, in the Vega repository. So let's go to, if you go to the Vega GitHub repository, so this is not VegaLite, just Vega. Maybe GitHub. Okay, and so if you click here, Vega, so it has lots of repositories, and one of them is all the data examples they put online. And so if you click, if you click repositories, yeah, I have to search for data. Oh, it's not here anymore. Vega. Oh, it used to have one. Okay, data. Okay, maybe call this one now, Vega datasets. And then inside the data, okay, now they called Vega datasets. And then inside the, inside the data directory, and these are the datasets that you can load directly in the online editor. Okay, so if you want to see the entire list, there's a file called the source.md. It listed all the files and have some brief explanation of what they are. Okay, this is just explaining to you and how to use this in writing code. But for example, you should be able to use any of these data sets and just by referring to a name. So if we go back to our editor here, the one we're looking for is weather Seattle.json. So this example, I think, is slightly outdated, and we can just search for weather. Okay, and we have a few files, and which is the one is and Seattle-weather.csv. So that's a bit different, not exactly the same as we want here. Or you have another one just called weather.json. And if we open up this one, it doesn't show you nicely. But I think, so again, itself is a, maybe using raw. Yeah. So this one shows the day, the record. No, I don't think this is the one. Nope, don't think this is the one. So they probably change that again. So as the, how do I say, the data itself and it's changing all the time, and so is the data set. The project in VegaLite itself is changing all the time. Okay, so maybe use this one. This is slightly easier to see, and you can see these different attributes: location, dates, precipitation, and temperature, maximum temperature, minimum, wind, and weather. So maybe just use this in our example. I'll make text a bit bigger here. No, it doesn't help. And so now we need to change the, oh, now it's changing. Oops. Changing the file name now to weather.csv. So that's the file. And if it's a CSV or JSON file and you don't need to do anything, and VegaLite should be able to parsing them directly. Oh, it still says can't read it. And also it does not have a field called temperature. In this case, what we call the temp underscore max. So we're gonna using the field, I'm gonna call it temper underscore max. Okay. Oh, it still couldn't find the file. Let's try again. Okay. And so in this case, I have to add data slash in front, just to tell it this is under the data directory, and then after that the weather.csv. Now it gets the data. Now you can see the validations get created here. So it shows automatically generates a kind of 1D chart and has axis, and the label is temperature max and depends on the value. In this case, it's the temperature, so it's between -10 and 40 degrees. And each line of these represents. Okay, and then you can easily change that to other type of validation. Let's go back to the slides. Just as we would change, say, if we want to change visual mapping, you can either change, say, one thing, you can change the mark, and you can change, I think, to point. And you got these points there, but obviously it's slightly hard to see. The other thing, you can also change the encoding. For example, you can map to x-axis. I think potentially you can also map to color. And we can do the same, and we can say we'll map and still use the same field, which is temperature max, but this and the same type. And this time is will be quantitative. Okay, and so in this case now you can see it generates, it's also mapped the temperature value to the color. This is generated for you. These are the minimum and maximum values, and you can see the shade of blue changes depends on the value. Okay, or you could just take this part out, then you only have the color, but then all the circles will be together, then it will be difficult to see. Maybe let's demonstrate. Oh, it doesn't like this. Line 6 encoding. It doesn't support comment out in the online, so you have to actually take it out. Okay, and in this case, you still have the same mapping, but all the circles are drawn here, multiple, so it doesn't really. Okay, and back to the slides. So we'll show you creating the very first VegaLite validation, probably the simplest possible one. Okay, and obviously this is not the best possible validation because there can be many lines overlapping each other, and you couldn't really see how many days are there for each temperature. Okay, so instead we probably want to say creating something like this, and which is a scatter plot or histogram. So I hope everyone knows what histogram is. So it breaks the value range into several bins, and then count how many values within each bin. This is mapped to the height of the bar there, so you can easily see where you had most values. So in this case, and it will be a bit more complicated in the sense, now we have 2 dimensions and not just 1 dimension. And also, and the x-axis is still the temperature, but now what we use the y-axis to show the number of records or rows for that data range. And then also the number of records for a particular data range, say between 5 and 10, that's not a value available from the data originally. So that's something you need to compute yourself in your code. Still, it's quite easy to do. Okay, and so this is what we had before. We set the data, we set the mark, and set encoding. Encoding here is mapping x to temperature or any other attributes in your data set. And in your examples, we're using temp max because that's how it is used in the data set. Okay, and to create the histogram, you need to add 1 extra line, say bin true. So that means you're gonna create these different bins, and that will be done for you automatically, but you have to tell VegaLite to do that. Okay, as we said, now we also need to add y-axis. Okay, and in this case, the y is not showing a particular attribute. So you're not saying field something, you're saying aggregate. And so that means we're going to do something derived values from the data we have. And in this case, will be the count, which shows the number of attributes in there in each bin. And then we say type equal to quantitative. And this is what will look like when you just do that. And finally, we change the mark from tick. That's why you have this line here to bar. And this is to give you then a bar graph, which is what we need. Okay, we're going to just do that now. In our example. So first, I'm going to just take away the color part. That's not something just we experiment with. So we have, and also change this one back to tick. So that gives the original tick graph or strip graph we start with. And now, okay, the first now, in terms changing the x-axis, and we need to add bin, double quote, and the value should be true. Okay, and the true itself, you don't need to put inside double quote, because if you do, then the true itself becomes a text. It's not a Boolean value anymore. Whereas if you just leave it as it is, it will be treated as Boolean value. And you can see now these ones are creating bins. Yeah. And the rest is the same. We can say field is still the same. The type is quantitative. Now we need to add our y-axis. So always remember to add a comma at the end of one property and key and attribute value pair. So key and value pair, yeah. So this one gonna have y. Specify y here. Okay, as we said, we are again double quote. Not using any particular attributes, and so we're not using field. Instead, we're saying this is one of the aggregates, and you can see these are different aggregates that is recognized. Ooh. And so you can do count, and you can do average, you can do minimum, maximum, and quite a few different ones. And then I think this might not even be necessary, and because the type can be easily derived from the data value. Okay, and then now this stage, which was exactly what we saw before, and the only thing we're missing is to change the mark and from tick to bar, because we want to use bar here. Okay, now we have our visualization and exact as this before. Okay, so as you can see, you still don't need that many lines of code, definitely a little bit more than before, but you only really specifying the minimum you need, the data source, the mark, and the channels. And if you have only one channel, then just do one. If you need two, you need two. And usually you wouldn't have three, but you could say set color or size as other channels. And then for each channels, and you just specify which field that's going to be used and the type of the attributes in that field. Okay, and then behind the scenes, there's other things that's being done for you by the VegaLite when you try to creating a histogram, because it have to calculate and select the data from each range and then calculate the number of the records or rows within each range. These are all done for. It can be translated into, say, a SQL query like this. But again, this is something you don't have to worry about. It's done automatically by the VegaLite. Okay, and also, VegaLite have to make a few decisions. For example, it have to decide and what are the minimum and maximum values, how many bins there should be, what will be the length of each bin, and all these things will be done for you by the VegaLite. And they try to make some reasonable guesses and using some like existing knowledge, what will be the best value for these. Okay. Okay, so this is slightly more complicated. So in this case, what we're trying to do is we are going to using one extra channel, and in this case is a color. So we already use the XY, which are the position channel, which are good for quantitative values. Now we're going to maybe add extra some information. In this case, we're going to show the weather type. So we had temperature range. So we know, say, for example, between 10 and you had most of the days and between 10 and 15. Then we want to show what are the weather like for those days. We're going to have these weather values. So in this case, we're going to use in field, and which says the type will be weather. Sorry, and the field name is called weather, and the type will be called nominal. So the nominal is the same as the categorical attributes we used in the book. And in this here, they call it nominal, and it essentially means the same thing. And that's all you need. Once you specify this, VegaLite would automatically assign color for each values for weather, and then shows a stacked histogram like this. Okay, we're going to demonstrate that in our code. So first, we just need to check the data, and if it's called weather in the data source, yes, and we do have the column called weather here. So we should be able to use it. So we just add one extra channel in this case, a comma again, and then this time color. And its field would be missing double quote here. Field will be weather, and it's okay. So you can actually see, even I just type weather, and it's already generated the visualization for me because it already guessed the type will be nominal by looking at the values in there. But you can always specify. Okay, and actually maybe this is also a good time to look at, say, it recognizes these four attribute type. And so it's ordinal and quantitative. These are what you talked about before. Quantitative is subset of ordinal. And the nominal is what we called categorical, so it's the equivalent. And temporal is something a bit different. So, and for this validation library, it treats the time as a special type of attributes. And they have something different, special way to show it, which we'll see later on. Okay, so that's all we need. So if you want to add this to this and add this color and use that to show the weather, that's all you need to do. Say, I want map the color to weather, and you might not even need to set the type because it can automatically and guess the data, the attribute type for weather is categorical or nominal, and then create the validation like this. Okay, again, there's many things done for you behind the scene. So it will try to find out, okay, what values available in weather, assign a color for each value, and it would pick the color which actually quite easily distinctive from each other. Okay, and back to slides. Okay, and if you want.
Professor, can you re-explain the slide 27?
27. This one?
No, the previous one.
This one?
No, it's the SQL code where.
Sorry, can you just be more specific? What is on the slide? So from what I can see, this is slide 27.
Yeah, this one.
Yeah, so these are the code. These are SQL queries or the equivalent of SQL queries. It just decides to select the right data to show in the validation. It has to return the number of rows within each of these data ranges. These are the things done for you automatically by VegaLite, so you don't need to worry about writing something like this yourself. So you don't need to understand what these things are.
Okay.
It's done for you, yeah, by the VegaLite.
Professor, about bin, I want the explanation, please. Bin, why we use this bin? And
Oh, okay. So the bin here is because if you want to create a histogram, the way the histogram works is to have a number of bins. So you need to put bin true here. Otherwise, it will just treat X as a field and map that to, instead of showing this as a. So we could change, for example, if we take out this one, then it will say x-axis are mapped to the temperature as a quantitative value. It will be shown as a bar, and it then would look like this.
Professor,
Yeah.
can we specify the number of bins?
Yes, you can. Yes, you can. I can't remember if we have examples later on, but definitely. And these are the things, if you want to, you can specify if you don't like the one that the VegaLite created for you.
What's the default choice of number of bins, Professor?
No, there's no one fixed numbers. It will depend on the value range, the size of the graph, and it will try to pick some values. For example, it knows if you have less than somewhere between 5 and 10 bins, that can roughly estimate that will be the good range it will target. But also it will also, for example, taking into consideration, you probably want to say the whole numbers, like the 0, 10, 20. It will not do say 11, 27 or something like that.
Professor, what according to you would be the ideal choice? Like when we have a huge chunk of data, so we would, it would be better to divide it into more number of bins or lesser number of bins. Which one is more visually appealing?
No. So again, so it's not about visually appealing. It really depends on your analysis. Sometimes you might need to have more breakdowns, very detailed, then you want to have smaller bins. And sometimes you just need to know roughly and the distribution, then you can have bigger bins. So here the bin is 5. And the size of the bin is 5, and which looks quite okay to me. And if it's a change to 10, that's also potentially also okay, but you have lose some of details there. And it's not about looks good, it's just about depends on analysis task. And currently I don't have any particularly analysis in mind, so it's difficult to say which one will be better, 5 and bin size of 5 or 10.
Thank you, Professor.
Yeah. And okay, go back to slides.
Professor, before you move ahead, can you tell me, like, how do you pull out that SQL statement? Can we see that SQL statement that is generated in the background?
No, you can't. You can't see the SQL statement. It's all done by VegaLite.
Okay.
So if you really want to control that part, so if you don't want to say VegaLite to calculate those things for you, and you have to do this manually yourself. Let me go there. You have to do this manually yourself and then save the results as part of the data as a new column or attributes in the data, and then using VegaLite to load it, if that makes sense. That's quite a bit of work you have to done manually. Yeah.
Okay.
Yeah, you couldn't change this part by yourself without changing actually the library code, VegaLite library code.
Okay, but would there be a scenario in which we would have to specify the queries explicitly?
No, not in VegaLite. In VegaLite, you don't do anything in terms of selecting the data, and all you need to do is to say, and you put bin or aggregate equal to count. Sometimes you say aggregate equal to average. That's also possible. Then it will do some SQL query, and it's calculated average of those values for you. But you don't write the SQL query yourself, not in the VegaLite.
Okay.
Okay, and back to the okay, and so this is a part. And if you don't, for example, if you don't like the color they picked, and for different weather, you could further customize yourself. And so you can further customize the color channel. And previously only said it's a nominal type, and the attribute name is called weather. And you can say, okay, this is how I like to measure it, to map it. So he said for these 5 different weathers are going to have these different 5 colors. And so these 5 are the values you have in the data set. You can't really change. And we can see drizzle, fog, rain, snow, sun. And so these are the 5 values. And these are the way you specify colors. And so you start with hashtag means, and these are hexadecimal numbers. And they're not decimal numbers in the sense hexadecimal. Okay. Can I see a show of hands? How many of you knows and what is a hexadecimal number? Okay. Yeah, a few. Okay. Not everyone. Okay. And so this hexadecimal number in short means, and instead of, so decimal number, I think everyone knows, it's from 0, 1, 2 to 9, and then you have 10, which is 2 digits, and 11, 12 to 19 and 20, etc. So you have 10, basically have 10 digits, 0 to 9. And in the hexadecimal number, you have 16 digits instead of 10. So that's quite useful for computers because computer is binary. So it is good. And everything that's to the power of 2, so you can have 2, 4, 8, or 16. These are all quite easy to be represented by the computers. And in this case, you would have 16. So you have 0, 1, 2, 3, all the way to 9. And then you don't get 10, you get A, which would be the equivalent of 10 in decimal number, and then B will be the equivalent of 11, and C, D, E, the last one will be the F, will be the equivalent of 15 in decimal numbers, and then you have 1, 0. Okay, I think this is slightly too difficult to explain. And then finally, these 3 represents, okay, maybe let me see if we have time. And if I have time, I can explain this a little bit more. Okay, maybe I can add a slide here. Okay, and so first we have the decimal number. So you have 0, 1, 2, and then all the way to 9. And you have basically these 10 digits. Okay. And what it's using here is called hexadecimal number. So you have 0 and 1, 2 goes on the same. You have 9, yeah. But here you actually in total have 16 different digits, maybe less. So after 9, you would have A, B, C, D, and E, and finally F. Okay, so these are like the new digits, the equivalent of 0, 1, or 2, or 4. And it just says now you in total, that will be 16, because you have 10 from here, that's before, and you have 6 more. Okay, so the A will be the equivalent of 10 in decimal number, and B will be the equivalent of 11, and so on and so forth. The F will be the equivalent of 15. Okay, so let's say in hexadecimal, and if you have something which is 10, so what it is actually, this is in, I think this will be, is equal to 16 decimal number. Okay, because the way it goes is it goes 0 to F, and then it becomes 10. Okay, so the 10 in hexadecimal is 16, but that's also, you can have some other numbers, looks like 1A or 2, say 3F, etc., etc. But this is why we see and these kind of numbers before. Okay, and then finally, back now, the way you specify color here is using the so-called here an RGB color. So that stands for red, green, and blue. So this is what the RG and B stand for. And then for each of these color, red, you use a hexadecimal, 2-digit hexadecimal number to represent the amount of red, green, and blue. So if you look at here, and you look at this number. Okay. So first, and you have this hashtag in front. So that tells you this is a hexadecimal number, not just a decimal number. And then this is the amount of red. And the next two is amount of green. And finally is the amount of blue. Yeah? And so the first 2 digits is the amount of red, the next 2 is the amount of green, and the last 2 is the amount of blue. Okay, and so you could have something like 0, 0, 0, 0, 0. This is all 0. And can anyone tell me what color is this?
White.
Someone say white. Anyone else?
White or black? Oh, I didn't remember.
Yeah. So actually 0 means no color, and no color actually means white. So sorry, black. That means you have no color at all. That means you have no red, no green, or blue. So that actually give you black, which we can try in a second. And oppositely, and if you have this, which is 1, 1, 1, oh, sorry, F, 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 F. Okay, so that's 6 F's. And again, so the first thing is, and in the hexadecimal number, because for each digit, the biggest you can get is actually F. It's not 9. And so if you have 2 digits, the biggest you can get is FF. So if you have the maximum amount of red, green, and blue. So what color is this? Anyone?
White.
Yeah. So this is actually white. In the sense, if you have the maximum amount of the 3 basic colors, you get white. And obviously, say, if you only want red, and you would have something, for example, FF, and then 0, 0, 0, 0. Or maybe your capital F, that's one, will be easier.
Professor, is it just the RGB color codes that we use over here? There are others as well, like CMYK and PMC. We don't use those codes.
I don't know if it does supports the other color. So the question was, say, instead of specifying using RGB, and there's other color space to different ways to specify color. I don't think it supports, and because this is essentially what you can do in HTML and CSS, I think it only supports this way of specified color.
Thank you, Professor.
Okay, anyway, so this one is the maximum amount of red you can get, as there's no green or blue, and it will give you a red color. Okay. Okay, okay, so we have to move slightly fast now, and let's go back to the slides. And so you could set your color, and then, so what you can do is you can set the domain, and then for each values of each nominal or categorical values, you give it a color. Okay, I might, just to save a little bit of time, I can just copy and paste this part. Oops. I'm gonna put it here, so it's gonna be inside my color, and I put that down. Okay, domain. It doesn't like this. This extra dots got added. So for these 5 values, we can have the range. Okay. Yeah, and so these are the different values now you set. For example, I can put in, for example, the first one. I'm gonna put in which is sum, and which is this one here. I'm gonna put in all zeros. You can see that gives you a black. And the next one, I'm gonna put in all zeros, and which should give you all FF. So that's the maximum value for all the attributes. Then that becomes white. And the problem here, the white, then you can't see because it's the same color as the background. And so usually what you can do is you can give it slightly less than FF. And if you have all three channels of the same color, it gives you a different level of gray. So in this case, I'm gonna using E, which is slightly than F. And you can see this is kind of very light gray here. Okay. And of course, if you want to red, you just give red, FF, and 0 other things. And that's green. And this is blue. Okay, so that's the maximum amount, which does not and looks slightly too bright for me. But I mean, this is just to show you how to set the color, and you can specify if you don't like the original color schemes, you can change them some other way. But I would just say the default color picked by the default color picked by the VegaLite is actually not bad at all. It's usually quite good. Okay, this is just what we typed. Okay, and for example, when you choose to add the color to the validation, the VegaLite, again, what it does is automatically choose to use a stacked histogram, and instead of the non-stacked version, because usually this is better. The non-stacked version basically means these bars are not on top of each other, but will be one in front of the other or on top of each other. So for example, and for this one here, which is between 5 and 10, you would draw a yellow one and then draw a purple one because it's too small, so you don't even see it here. And then you draw the blue one. The blue one is quite high, so you can see a little bit blue, but the blue actual value is between here and here. And finally, the gray one will be drawn here. So these all overlapping each other, whereas the VegaLite help you to do this. Choose this option instead of this option because it knows this will be better usually. So here, because you use the color channel and you use the mark as a bar as a mark, and it automatically creates a stacked bar chart. Okay, and as we already mentioned this before, so even this is quite a nice layout, nice visualization. And if you want to compare the amount of particularly weather, and it can be still a bit difficult to compare. For example, if you want to compare the amount of the foggy weather between this temperature range and this temperature range, because they are not next to each other, and also they are not aligned, so the start point is not there. So it's a little bit harder to compare. Even though I think most people would say this is bigger than this, that's quite easy to see, but in terms of how much bigger, might be a bit more difficult. Okay. So what you can potentially do is you can break this one down into multiple histograms. Okay, so this is the thing before, and it's using the color to show. Next one, it still uses color, but what it did extra is say it add a column. So now each weather value becomes a column. And then, so now you can see this is all the days which are drizzle in different temperature range. And that's for rain, this is for sun, snow, and fog. Okay. So if you want to compare the number of days for different weather conditions, then this might be a better choice. Okay, and all you need to do is just changing this part from color to column. That's all you need to do. This just basically says I'm going to using column to do this. Okay, and if you just do that, the results you get is like this. It's still okay, and the problem is not using any color to show different weather type. And obviously, if you want, you can just add this back, and this time, say instead of column, I'm gonna just basically change back to color. Now you have
Professor,
yeah.
how to create the no stack one?
The what statement?
No stack histogram.
No
So when
stack.
you have, yeah.
Oh, okay. No, that's a bit more complex. If you want to do a no stack one, you have to do it a bit later. And I can't remember right now. It just says the default value when you choose bar, and then I think it's bin. Sorry, bar and color. If you don't want to stack, I have to check exactly how to do that. Okay. But yeah, okay. So this is the. So if you just want to have multiple columns, it's very easy to do. Just add this part, and obviously, if you want to color, you have to still keep that one. Okay, so all so far, and we have done this, and inside the online editor, and then, so when you actually do it, and you probably want to do it and in your own code, so creating the HTML file, just as we before, and add a little bit JavaScript in that as well. So because one of the main problems is here, whatever you created here in the online editor, you can't really save. Settings, yeah. So basically next time, if you go back there, it will just be gone. And this is really just only for you to test it out. And so if you want to save, and sometimes it's probably easier, is actually to do it locally, just creating the HTML file and do that. Let me get back here. So this is what it look like. I'm going to go through this, and in a second, we have about 7 minutes left. And okay, obviously, and this is the part, the text will be way too small. You probably can't read. We're going to expand that a little bit. So first, as we said, in the header part, which is the metadata of the document, the things does not show up in the page, you need to add these. Okay, these are the 3 script tags you usually just copy paste, and these are the ones which load the files needed, or the library files basically. So once you add these, then you can use VegaLite. Otherwise, you will not be able to use any of those commands, because those are VegaLite specific commands. You need some extra files, just like say, and in Java, you have to import something. Okay. And then in the actual validation, I'm not sure if it's visible, and you need to define a element, in this case called div, with the ID called viz. So this is where the validation will be bound to or be displayed. And this is the part very similar to what you wrote in the online editor. So this is the actual VegaLite specification. And again, we're going to go through that later. And finally, you add this line, which links the specification you created to the element on your page. And then you would get something like this. Okay, and so we're going to do that now. Okay, so this is what actually it would look like, and very similar to what we just talked about here. Not this slides, and that page up. And like this one here, okay, and I'll make this text bigger. And so what you have is, these are the same as before, and doc type and HTML head section. And these are the 3 lines you have to include to use anything VegaLite on your page. And so you have to, and in most cases, you just copy paste every time. And that's all. And then this is your body part. And you can have some, you need to define some div element. So this is where you will have your validation displayed later, and you can have multiple ones because you could add other things like H1, title, and say some text. Hold in here. Say paragraph for the visualization. Etc. etc. And then you have a div. So then the validation, when it's bind to this div, it will appear after the H1 and the paragraph here, for example. And maybe add another piece, say paragraph after the visualization. And also you can have multiple validation as well. And you can have another div which links to a different visualization specification. Okay, and here, and for all the VegaLite specification, it has to put in between the script tag because it's JavaScript code. And what you do, and you define a variable, var says variable. The variable names can be anything. And in this here, I say it's called a VL spec. It stands for VegaLite specification. Again, that's not required. So in this case, the data part is a bit different than we did before in these examples. So here we're just using a URL. In here, we actually list of all the data we're going to have. So these are the data we have, which is 0, 1, some points, basically X and Y coordinates. And so what I'm going to do, the mark will be line. And then I say the X-axis will be X field, which is these here. And the Y-axis will be my Y field, which will be these here. And it's going to be quantitative. So these are all numbers. Okay, so this is very similar to what you would have wrote, or this part, in the online editor. You specify the data, the mark, and encoding. Okay, finally, you have this part. What it does is it binds the validation, which is specified here, with an element on your page. So here it says hashtag #viz, which refers to this element, because this element has an ID called viz. So it says I'm going to bind this element to VL spec. You can see VL spec is a variable which defines everything else, everything inside here, which is VegaLite. So that one will say, okay, when this div on the page will actually display this validation. That's what this part does. Okay, I'm gonna just comment these one out for now. And if I go show you on the VegaLite page, you can see this is what we got. Then basically these are the points we have. In this case, we're using line, so they get connected. For example, I can change this to a point. And you can see now the ocean becomes a point. If you use line, they get connected. So this is creating our first validation. And you can see we have the page title here, and this is the first paragraph, and that's this paragraph here. And then I had this div. That's why I get this validation positioned here, because that div with this is bind to VL spec, which is this one here, and then had another paragraph after the div. That's this paragraph here. Okay. And finally, you can have multiple validations as well. So in this example, I had a second div, which is that had ID called vis2, and then here in the code, and I bind vis2 to VL spec2, which is this variable here, and it has its own encoding. And if I save this one here now, and it will create a second validation here. So that's where this div is inside the page, and this will bind these data to using the validation defined here and displayed here. Okay, so you can, and similarly, you can add a third one, etc., and go on. You can add as many as you want. And in between these validations, you can add, say, text, paragraphs, titles, pictures, list, anything else you want as well. Okay, yeah. Okay, that's it. And we run slightly over time. That's where we'll stop now. And is there any questions?
Professor, have we done this on Visual Studio Code?
Yes. The one I showed you today, just now, is done in Visual Studio Code. But essentially, it's just creating an HTML page. If you don't use HTML code, you can use any other code editor that also works.
Okay.
Yeah. Okay, and that's it now for today. I'll stop the recording now.